everyone, welcome to another day, another chapter. That is, we are going to start today the chapter 7 of your higher math book. So in this chapter, we are going to discuss about infinite series. So let us move on to the class contents and learn what we are going to learn today. So first we are going to learn about sequence. What is a sequence? And then we are going to learn about series, and finally we are going to learn about infinite series and its sum, and finally we will move on to the solution of the problems of exercise 7. So there is the control panel. So let us move on to what is a sequence. So when some numbers are arranged successively under a definite root such that the relationship between any two successive terms is known, then the set of numbers arranged in this way is called a sequence. So let us first actually find a relation. So the first relation we can find is having some problems with the board. So let me know on pen. So let us see what a sequence of relation. So first we need to define a relation. So if we define a relation as n squared, okay. So n squared is the basic relation between between two successive terms of a sequence. So if n is equal to 1, we will get 1. If n is equal to 2, we will get 4. If n is equal to 3, we will get 9. What happened? It is not responding. So we get 9, we then get 16, then 25, then 36, then what? 49. So these are actually a sequence of numbers that has the common relation of n squared. So if I write them using 1, 4, 9, 16, 25, 36, 49, we will get a sequence. Okay. So similarly, we can write a sequence using the relation 2n plus 1. So when n is 1, so n equal to 0, we get 1. When n is equal to 1, we get 3. So n is equal to 2, we get 5. So n is equal to 3, we get 7. So see, we are actually creating a sequence of odd numbers. So if I actually write them in sequence form, I will get this sequence. So 1, 3, 5, 7, 9, and so on. Okay. So this is how we actually create a sequence. So now that we've learned about sequence, we're going to learn about series. So what's a series? So basically, if the consecutive terms of a sequence are added by a plus sign, we call it a series. For example, you can remember this part. This was actually a sequence of square numbers 1, 4, 9, 16, okay. So now what we did was actually remove these commas and bring up some plus signs, that is add them up. So 1 plus 4 plus 9 plus 16 plus 25 and okay. So now we have actually replaced the commas with with a plus sign, and we have actually formed a series. Similarly, this is another series. The general relation of this is actually 1 by 2 to the power of n, maybe, because it could be 1 by 2 to the power of n minus 1 most probably, because in the first term we get half. So first term is half, which can also be written as 1 by 2 to the power of 1. Similarly, the second term is 1 by 4. So we get 1 by 2 square. And the third term is 1 by 8. That is 1 by 2 to the power of 3. Okay, so it will be actually 1 by 2 to the power of n. So it's not n minus 1. So 1 by 2 to the power of n is actually the common ratio between these terms or of this series. Okay, so see how a series is formed. So let's move on to the next part, that is there are two types of series. You have learned this in your general math book, I guess. So first one is geometric series, when the ratio between two successive terms of this series when the ratio between two successive terms of any series is same. That means first term and second term divided by first term is equal to r. So we see that in any series, if we actually divide the second term by its first term, we get a ratio. Similarly, if we divide the third term by the second term, we will get the same ratio. Similarly, fourth term by third term, fourth by third, we'll get the same ratio. So all the ratio of consecutive terms are actually same in a geometric series. Okay. So some examples of geometric series can be, let me see what can be the example of a geometric series. So 1 plus 4 plus 16 plus 16 over 64. Because here we see that 4 divided by 1 is equal to 4. 16 plus divided by 4 is also 4, and 64 by 16 is also 4. You see, we have actually constructed a geometric series quite easily. So all these terms have common ratios, all these two successive terms have common ratios, and these terms are they actually create a geometric series. Okay. So now we move on to the arithmetic series part. The second type of series is actually arithmetic series. So when the difference between two consecutive terms of a series are constant, it's an arithmetic series. Okay. So you know the general formula of arithmetic series, that is a plus n minus 1 d. So here d is difference and a is first term. Okay. So sum of variation of arithmetic series is 1 plus 3 plus 5 plus 7 plus 9 plus ... You will see that there is a common difference between these two terms. Similarly, these two terms also have a common difference, that is 2. 3 minus 1 is actually 2. 5 minus 3 is also 2. Similarly, 7 plus 5. 7 minus 5 is also 2. And 9 minus 7 is also 2. So this is actually an arithmetic series because the difference between two consecutive terms are actually equal to 2. That is, they are same. Okay. So these are the two types of series based on the nature of the consecutive terms. But there is also another two types of series based on the number of terms. One is infinite series and another one is finite series. Okay, so infinite series means there are a huge number of terms in this series. That means it's an infinitely long series, and finite series basically has a end point, is a known end point, which infinite series doesn't have basically. So I guess we have talked about finite series in your general math book or in your also in lower class. I guess I don't know if it was taught in class 8 still, but I'm not gonna actually spend more time on the definition of finite and infinite series.